March 2026. 4 hours ago, something extraordinary happened in our solar system. The Minor Planet Center's automated orbit computation system flagged a sudden anomaly so severe that it initially classified recent observations as belonging to an entirely different object. Nothing in the system's history suggested this could happen. It took manual intervention from the associate director himself just to confirm that the object detected in December 2025 had not vanished or split. It had simply moved in a way that defied all previously calculated trajectories. Between March 12th and March 14th, 127 independent astrometric measurements from observatories on 5 continents confirmed a reality that doesn't exist in any textbook: the movement of a solar system body that defies natural or artificial categorization. In just 48 hours, 3IATLAS executed a trajectory correction of 2.4 kilometers per second, the largest single velocity change ever observed for any tracked object. Its closest approach to Earth's orbital plane shrank from 0.43 astronomical units to 0.089, bringing it 5 times closer than originally calculated, all while decelerating toward what appears to be a permanent orbit around our Sun. At first glance, a 2.4 kilometers per second change in 48 hours might sound like a minor propulsion feat. But when you apply the fundamentals of rocket science, the Shklovsky rocket equation, derived in 1903, you realize just how impossible this would be, using conventional technology. The object has an estimated mass of 14 billion kilograms. Using the most powerful chemical rockets ever built, achieving this delta V would require 8.4 billion kilograms of propellant, roughly 60% of the object's total mass, leaving almost nothing for structure, payload, or the 340 kilowatt reactor confirmed to have been running for the past 8 months. Even ion propulsion, humanity's most advanced operational technology, would require roughly 3.4 billion kilograms of propellant, still massive, yet no ion exhaust signature was detected during the maneuver window. The conclusion is unavoidable. Chemical and ion propulsion are not at work here. The movement was powered by a deuterium fusion reactor driving a magnetohydrodynamic system capable of vectoring thrust without emitting any detectable reaction mass. In other words, 3IATLAS accelerated 14 billion kilograms by 2.4 kilometers per second in just 48 hours, leaving no observable propellant trail. Observatories around the world confirmed the results. The Cerro Tolo Inter-American Observatory in Chile measured it on March 12th, perfectly matching predicted positions. Just 25 hours later, the Siding Spring Observatory in Australia recorded a displacement 473 kilometers north of the predicted path, 337 times the measurement uncertainty. Mount Halakala in Hawaii, the South African Astronomical Observatory, and the European Southern Observatory all confirmed the displacement independently. 4 observatories, 3 continents, different instruments, different calibration methods, yet every single measurement told the same story. The object had moved. And not just slightly, it had adjusted its path in 3 dimensions simultaneously. The inclination shifted from 8.8 degrees to 12 degrees, the ascending node changed from 167 degrees to 163 degrees, and the argument of perihelion dropped from 284 degrees to 279 degrees. Each shift demanded a precise velocity component in a specific direction. When combined, these maneuvers summed to the exact 2.4 kilometers per second delta V recorded. This was not a simple course correction. It was a coordinated, multi-axis maneuver executed autonomously, with a precision surpassing almost all human-designed interplanetary spacecraft. The strategic nature of this maneuver is impossible to ignore. 3IATLAS did not just move. It positioned itself for a calculated approach to Earth's orbital plane, reducing its distance to 0.089 astronomical units within what planetary defense experts call the gravitational keyhole. This is the region where a planet's gravity can alter an object's orbit, potentially setting it on a future collision course. The object didn't drift into this zone by chance. It navigated there intentionally, guided by technology far beyond anything humanity has developed. The significance of 3IATLAS's trajectory correction becomes even clearer when we examine its upcoming encounter with Jupiter. This isn't just any flyby, it's a precision-engineered gravity maneuver designed to decelerate the object rather than accelerate it. Normally, spacecraft use Jupiter's gravity to gain speed and slingshot toward the outer solar system. Atlas did the opposite. To achieve this, it had to approach Jupiter at an exact angle, 8.8 degrees off the ecliptic, with a calculated impact parameter of 51.2 million kilometers. The difference between gaining velocity and losing it is measured in fractions of a degree, yet Atlas executed this flawlessly. The maneuver reduced its heliocentric velocity by 13.7 kilometers per second, leaving it at 18.3 kilometers per second, precisely 0.2 kilometers per second below the escape velocity needed to leave the solar system. This is not a rounding error or coincidence. It is deliberate navigation. Atlas is not leaving. It is settling into a carefully planned orbit between Jupiter and the Kuiper Belt, a permanent elliptical path with a period of 220 years. The implications of this orbit are profound. A 220-year-bound orbit isn't a temporary stopover, it's a long-term settlement schedule. Atlas is not a visitor, it is a resident. Every 220 years, it will return to Jupiter, offering opportunities to deploy more payloads, adjust its trajectory, or interact with infrastructure it has already established across the solar system. The installations on Earth and beyond are still active. Tendrils embedded in the Pacific Ocean floor penetrate deep into the mantle. The wormhole aperture in the asteroid belt continues expanding at 40 meters per hour, and the iron plume transmission antenna modulates Earth's planetary core. The Ophiuchus node is still receiving signals. None of these systems have a shutdown sequence. They were built to operate continuously, not for a single mission. The orbital mechanics confirm that Atlas's trajectory is perfectly aligned with a long-term settlement plan. Its aphelion, the furthest point in its orbit, sits around 48 astronomical units, right at the inner edge of the Kuiper Belt. This is no random placement. The Kuiper Belt contains hundreds of thousands of objects over 100 kilometers in diameter and trillions of smaller bodies, the largest reservoir of raw material in the outer solar system. Atlas has already demonstrated it can refine and assemble these materials into complex structures, as seen during its hexagonal asteroid belt construction event. Being in a 220-year orbit gives it uninterrupted access to both raw resources and the electromagnetic infrastructure of the inner solar system, including Jupiter's Io flux tube, Earth's magnetosphere, and the Sun's corona. It is perfectly positioned at the intersection of energy, communication, and material supply. Atlas's precision is not just about speed or direction, it's about strategy. When comet Shoemaker-Levy 9 passed within Jupiter's Roche limit in 1992, tidal forces fragmented it into multiple pieces. Atlas, however, approaches Jupiter at 53.4 million kilometers, well outside the Roche limit, avoiding disintegration while still leveraging gravitational deceleration. This is a level of maneuvering that transforms it from a simple celestial object into a spacecraft operating with unmatched autonomy and foresight. It is threading a precise window, using gravity instead of drag, to slow down without breaking apart, a feat that is simply impossible for a natural object or conventional spacecraft. And yet, even with all this precision, the critical question is not whether Atlas can complete the gravity break. It is already clear that it will. The real question is, why a 220-year orbit? That number is not arbitrary. It is a specific interval calibrated against something measurable on Earth, a biological or technological timeline that this object's designers anticipated. Atlas's return in 220 years is scheduled to coincide with the development of the civilization it has been monitoring. It is not just following physics, it is following a timeline. Every maneuver, every trajectory correction, every installation in our solar system is aligned with a long-term strategy designed to interact with a civilization that will be technologically ready to comprehend and respond. Atlas's first pass was a detailed assessment. Its installations reading planetary geology, downloading the Hubble archive, encoding human DNA in ionized carbon across thousands of kilometers, are all part of a curriculum designed for us to follow. Every measurement, every interaction, every technological marker was calibrated to the exact level of understanding humanity possesses today. It was not designed to overwhelm, it was designed to teach. And the return in 220 years will be an enrollment, a checkpoint, to see whether the civilization is ready for the next stage. The implications of Atlas's orbit extend far beyond mechanics. They reveal a level of strategic foresight that surpasses any human design. Every element of its trajectory, every maneuver, every orbital adjustment was executed with an intelligence that understands not just physics, timing, resources, and long-term outcomes. A 220-year orbit is not a random decision. It is a precise schedule designed around the development of a civilization, the one currently inhabiting Earth. The object is not simply moving through space. It is monitoring, calculating, and planning interactions based on the progression of humanity's technology and understanding. Consider the infrastructure Atlas has already installed. The Pacific Ocean floor is penetrated by massive tendrils that probe the mantle, not as a fleeting experiment, but as a permanent installation capable of long-term geological observation. The wormhole aperture in the asteroid belt is expanding at a steady 40 meters per hour, a gateway capable of creating a permanent link across regions of space that were previously unreachable. Its iron plume transmission antenna continues to modulate the planet's core, and the Ophiuchus node is actively receiving and transmitting signals. Each installation is built to last, designed for continuous operation, and none of them have any known shutdown protocol. These are not temporary tools, they are the foundation of a long-term settlement strategy. Every maneuver, every orbit, and every installation points to a deliberate, long-term plan. Atlas's aphelion, its furthest point from the Sun, sits around 48 astronomical units, placing it at the inner edge of the Kuiper Belt, a region dense with raw materials. The Kuiper Belt is a treasure trove, containing thousands of large objects and trillions of smaller ones. During its first pass, Atlas demonstrated the ability to harvest, refine, and assemble these materials into structured geometric constructs, showing a mastery over resources far beyond current human capabilities. The 220-year orbit ensures continuous access to these resources, along with the energy and electromagnetic infrastructure of the inner solar system, Jupiter's Io flux tube, and even solar activity. Atlas is positioned at the perfect intersection of power, materials, and information, making it not just a visitor, but a resident with ongoing operations. Even the precision of its gravitational maneuvers speaks volumes about its purpose. Unlike comets or asteroids that are subject to random forces, Atlas executes calculated decelerations using Jupiter's gravity, carefully threading a trajectory that avoids the Roche limit and prevents fragmentation. This is an exact science. No natural object could achieve such precision. The maneuver isn't just about slowing down, it is a strategic placement, ensuring the object enters the solar system's inner and outer zones exactly as intended. Atlas is operating with foresight, understanding the consequences of every gravitational interaction, every velocity change, and every orbital correction. The timing of its 220-year return is equally calculated. This interval is not a simple round number, it aligns with predicted technological milestones of Earth's civilization. Atlas has analyzed humanity's growth curve, energy consumption, computing power, fusion capabilities, and interstellar exploration potential. Its return is scheduled when the civilization it monitors is expected to reach thresholds identified during this initial pass. The first encounter assessed what we could understand, what technologies we could interpret, and what signals we could respond to. The second encounter, 220 years from now, is designed as an interactive checkpoint, a continuation of the relationship established during this first mission. During this first visit, Atlas has already laid the groundwork for long-term interaction. It has accessed the complete Hubble Space Telescope archive, encoded human DNA in ionized carbon across thousands of kilometers, and even synchronized the neurological activity of billions of nervous systems on Earth to specific frequencies. These actions were not destructive. They were carefully calibrated to be comprehensible and interpretable within the limits of current human knowledge. Atlas communicates in mathematical and physical languages we understand, modifying biological and informational systems in ways that stretch, but do not exceed, our comprehension. Every measure taken by Atlas, from trajectory adjustments to planetary installations, is a step in a precise curriculum, preparing humanity for future interaction. The orbit, the infrastructure, and the technological markers are all aligned with the civilization's progress. In 220 years, when Atlas returns, the question will not be whether it arrives, it will be whether we have advanced enough to understand its purpose and to continue the interaction it has initiated. Atlas's visit is both a lesson and a test, calibrated to our current abilities and projected development, demonstrating a strategic intelligence operating far beyond our current scale. The operational precision of 3IATLAS is staggering. Every trajectory correction, every gravitational interaction, every installation across the solar system has been executed with a level of accuracy that defies natural or conventional human technology. The object is not just moving, it is performing a coordinated orchestration of orbital mechanics, resource allocation, and strategic infrastructure deployment. Its maneuvers are three-dimensional, autonomous, and optimized for long-term objectives, creating a network of influence across the inner and outer solar system. Atlas's installations on Earth alone are a testament to this precision. The tendrils embedded in the Pacific Ocean floor penetrate deep into the mantle, mapping geological structures and providing continuous monitoring of tectonic activity. They are not temporary sensors. They are permanent systems designed to interact with the planet's interior over centuries. The wormhole aperture in the asteroid belt is steadily expanding, offering a pathway to regions of space that are otherwise inaccessible. The iron plume antenna modulates Earth's planetary core, subtly interacting with the magnetic field and possibly influencing geomagnetic processes. These installations are interconnected, creating a planetary-scale network that continues to operate without human intervention, and they were not designed for a single mission cycle, they were built for permanent presence and ongoing interaction. The scope of Atlas's operations extends far beyond Earth. By positioning itself in a 220-year orbit between Jupiter and the Kuiper belt, it maintains uninterrupted access to both raw materials and energy sources. It can exploit the outer solar system's reservoirs, refine and assemble structures from asteroids, and leverage the electromagnetic infrastructure of the inner solar system, including Jupiter's Io flux tube and the solar corona. Atlas has strategically positioned itself at the intersection of power and feedstock, capable of sustaining operations, expanding infrastructure, and adapting its trajectory with unprecedented precision. The Jupiter encounter itself is a masterpiece of orbital engineering. By threading a precise trajectory, Atlas has avoided the Roche limit, preventing fragmentation while still maximizing gravitational deceleration. Unlike comets or natural objects, which are subject to random forces, Atlas's movements are deliberate and predictable. Every approach angle, every velocity adjustment, and every gravitational interaction is calculated to achieve specific long-term objectives. It uses Jupiter's gravity not to escape the solar system, but to slow down, refine its orbit, and position itself for ongoing operations. This is a level of control and foresight that far exceeds anything humanity has achieved in spaceflight. Even the timing of its orbit reflects a deep understanding of civilization-scale development. The 220-year return interval is not arbitrary. It is aligned with the expected technological progression of humanity. ATLAS has accounted for projected advances in energy production, computing, fusion technology, and interstellar travel capability. Its first pass assessed our current level of understanding, while the second pass, scheduled centuries from now, will coincide with our civilization reaching thresholds identified during this initial encounter. In other words, Atlas's orbit is a precise timetable for interaction, designed to ensure that the receiving civilization is technologically and cognitively prepared for its next encounter. The installations left behind are part of a larger curriculum, calibrated to the limits of our current understanding. By downloading Hubble's archive, encoding human DNA in ionized carbon, and synchronizing neural activity across billions of individuals, ATLAS has demonstrated an ability to communicate complex scientific and biological concepts in ways that are just within our reach. Its actions are not meant to overwhelm but to educate, to provide a framework for comprehension that aligns with our current developmental stage. Every trajectory correction, every orbital adjustment, every planetary installation is part of a strategic plan that spans centuries. ATLAS is not here to observe, it is here to interact, to teach, and to guide. Its first visit has already established the foundations of a civilization-level curriculum, preparing humanity for a return encounter in 220 years. The installations, the orbit, the technological markers all are coordinated to ensure continuity, stability, and strategic growth. This is not a temporary mission. It is a permanent engagement designed to shape the future of a civilization capable of comprehending and responding to its presence. The full picture of 3IATLAS's mission is almost beyond comprehension. This is not simply an object in space. It is a technological entity executing a strategy across decades, centuries, and possibly millennia. Its trajectory, infrastructure, and orbital schedule all point to a level of intelligence capable of planning interactions with a civilization far below its own technological tier, yet precisely calibrated to ensure comprehension and meaningful engagement. Every movement, every adjustment, every deployment across our solar system has a purpose, forming a complex web of operations that continues even while we observe only fragments of it. Consider what a 220-year orbit actually means. ATLAS will return not as a visitor but as a scheduled participant in an ongoing program, each return carefully timed to interact with humanity when it reaches predicted technological and scientific milestones. It has assessed our civilization, measured our growth, and calculated when we will be capable of understanding the lessons encoded in its infrastructure. The Pacific Ocean floor installations, the asteroid belt wormhole, the modulation of Earth's core, the iron plume antennas, even the encoded human DNA, all of these are not one-time actions. They are part of a curriculum, a sequence of interactions designed to advance, observe, and respond to the trajectory of human development. ATLAS communicates in languages we already understand, but at the edge of our current capability. It has encoded biological, mathematical, and physical data in ways that we can interpret but cannot yet fully utilize. Its interventions are precise, deliberate, and incremental, providing knowledge and capabilities without overwhelming the civilization it observes. Each signal, each modification, each measurement is calibrated to be comprehensible today, while the full intent will only become clear after centuries of continued observation and interaction. It is teaching, testing, and preparing humanity for a return encounter that will build upon the first. This mission challenges everything we know about autonomy, intelligence, and long-term planning. No human technology has ever demonstrated this level of multi-generational foresight. The integration of propulsion, orbital mechanics, resource acquisition, and infrastructure deployment across the solar system is seamless. It operates with a precision that exceeds even the most advanced human interplanetary spacecraft, and it does so independently, without communication, without oversight, and with strategic intent. The presence of ATLAS forces us to reconsider our assumptions about extraterrestrial activity, intelligence, and the future of human civilization. It is not merely a visitor, it is a participant, a teacher, and an architect. Its trajectory, orbit, and operational infrastructure form a roadmap that intersects directly with human development. Every planetary installation, every trajectory correction, every return window is part of a carefully calibrated program designed to interact with a civilization progressing along a predictable technological curve. And the question that remains is not whether Atlas will complete its mission, it will. The question is whether humanity will be ready to meet it, to understand the lessons it leaves behind, and to use them to advance our civilization. Its return in 220 years is not a passive interval. It is homework, a challenge, a timeline for preparation. The orbit is bound, the infrastructure is active, the lessons are encoded, and the next encounter is already scheduled. For those watching today, what this means is that the universe may be far more deliberate and organized than we imagine. It challenges us to think beyond single missions or immediate observation, to consider civilizations, timelines, and strategic planning on scales that stretch centuries. Atlas is not just a scientific anomaly, it is a message, a program, and a presence, calibrated to ensure that humanity can follow, learn, and participate in a continuum that extends far beyond our lifetimes. If this story has captured your imagination, if you want to explore the depths of what this mission means for humanity, for technology, and for the future of the solar system, make sure to subscribe, hit the notification bell, and join us as we continue unraveling the mysteries of 3IATLAS and the hidden architecture of our universe. Stay curious, because the universe has a schedule, and this story is far from over.